Hello, welcome to another episode of Learning Mathematics. We are still on plane coordinate geometry and we are now on distance formula. So the competencies or the target objectives for this lesson is to derive the distance formula, determine the distance between 2 points, and use the distance formula in deriving the midpoint formula, and use the two formulas in solving problems related to plane geometry. So the distance between any 2 points on a number line, whether it's horizontal or vertical, is simply found by the length of the segment. For example, let me use another color of a pen. For example, if I have a point here and another point here, if we're going to get the distance or the length of the segment formed, we can simply count 1, 2, 3, 4, and 5. So the distance is, or the length is 5 units. Or we can simply subtract 3 and -2. So the answer is still 5. That's for horizontal. For vertical, example, if I have a point here and another point here, the distance between 2 points, again, we can count 1, 2, 3, 4, 5, 6, or simply get the difference between the 2 points, which is 3 minus -3, which is equal to 6, or 6 units. That's the distance. This is good if the distance between 2 points or the points are, or the segment is either horizontal or vertical. What if the segment is neither horizontal nor vertical, but a slanting line? And it talks about, or it involves 2 points on a coordinate or Cartesian plane. So let us recall that the Cartesian coordinate system, or the Cartesian plane, is coined after René Descartes. So let's just have, for example, we have a point here and another point here. Let's call this as our P1 and this is our P2. Our P1 has coordinates x sub 1 and y sub 1, while our P2 has coordinates x sub 2 and y sub 2. Now, we want to get the distance between P1 and P2. We can no longer apply the counting or the getting the difference between the points because it's not horizontal nor vertical. Notice that if we're going to draw a vertical line here and a horizontal line here to a certain point, let's call this Q, it forms a right triangle. Now this Q here takes the point for x, this will be the x sub 2, right? We will have the same abscissa. For y, it will take the y of the point 1, which is y sub 1. Okay? Are you still learning? So let's prove. So this one here is, the point 1 is 1, -1. While the point 2 is 1, 2, 3, 3. Y is 1, 2, 3. Still 3. Okay? Now this Q here is 3 and -1. So again, this is the meaning of having the coordinates of Q, which is x sub 2 and y sub 1. So if we want to get the distance between this point 1 and point 2 here, we can use the Pythagorean theorem because again, it is forming a right triangle. If we can have our A here and the B here, this will be our C. So the Pythagorean theorem states that C is equal to A squared, C squared is equal to A squared plus B squared. Therefore, the point 1 here, or the distance between point 1 to point 2 squared is equal to, our A is the distance between P and Q with the absolute value, or the absolute value between the absolute value of the difference. So we have PQ, or the point 1 to point 2 is equal to PQ. Let me change that. It's equal to PQ, P1Q plus P2Q. Here, this is our A and this is our B. Our A is the distance between P1 and Q, and our B is the distance between P2 and Q. Again, we are still on the process of deriving the distance formula, right? So P1Q has, if you see P1Q, because it's already horizontal, simply subtract the abscissa. So P1Q is equal to the absolute value of the difference between 3 and 1, or simply x sub 2 minus x sub 1. While P2Q, because it's vertical, subtract only the abscissa are the same. Subtract only the ordinates, which is 3, the absolute value between 3 minus -1, or simply y sub 2 minus y sub 1. Therefore, P1 P2 squared is equal to the absolute value of x sub 2 minus x sub 1 squared plus the absolute value of y sub 2 minus y sub 1 squared. This is squared. This is from this one here, using the Pythagorean theorem. Deriving the distance formula further, we have point 1 to point 2, which is, this is our distance formula, is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1. So this is now our distance formula. Alright? Now let's have few examples using the distance formula. Okay. Suppose we have point A with coordinates -3 and 1, and point B with coordinates 0 and 5. We're going to plot this in the coordinate plane. Again, 3 and -1, so we have 3 and -1 is here, and 0 and 5, 1, 2, 3, 4, 1, 2, 3, 4, 5 is here. So this is the A, and this is the A. So distance from A to, so using the Pythagorean theorem, or the distance formula, you can have AB equals the square root of x sub 2, which is 0, minus -3 squared plus 5 minus 1 squared. So we have, move it, 0 minus -3 is +3, squared is 9, plus 5 minus 1 is 4, squared is 16. So we have 9 plus 16, square root of 25. AB therefore is 5 5. So the distance from A to B is 5. Okay, that is using the distance formula. Let's have one more example. So we have C with points -2 and 5, and D with coordinates 6 and 1. So we have CD equals the square root of x sub 2, which is 6 minus -2 squared plus 1 minus 5 squared. So CD square root of this is 8 squared plus -4 squared. 1 minus 5 is -4 squared. My pen. CD equals 64 plus 16, which is equal to the square root of 80. 80 is not a perfect square, so it's fine. 80 could be equal to 16 times 5. 16 is a perfect square with the square root of with a square root which is 4. 5 is no longer a perfect square, so this is sorry, not C, not AB, but CD. Okay, regardless of which point, even if this will be our point 1 and this will be our point 2, or the other way around, we will still arrive with the same answer because it talks about distance. Okay, now let's proceed to using the distance formula in deriving the midpoint formula. Okay, midpoint, when we say midpoint, it divides a segment into 2 equal parts. So let's go back to the vertical and horizontal number line which we used a while ago. So here, the midpoint is, if this is 2, the midpoint is somewhere here. It's 0.5. So how do we get the midpoint using the points? So we have the average, the midpoint is the average between the 2. So we have 3 plus -2 divided by 2 because it's the average. 3 plus -2 is 1 over 2. So it's equal to 0.5 or simply 1/2. Therefore, the midpoint is here. Alright? How about this vertical line? So the midpoint, looking at the figure, obviously the midpoint is 0. So 3 units here and 3 units there. But how do we get the midpoint using the given point? So we have 3 plus -3 divided by 2, which is 0 over 2, 0. So we have here the midpoint is 0. That's good if the segment is either horizontal or vertical. What if the segment is slanting line? So we can still use the concept of the average between the abscissa and the ordinates. So let's have an example. How do we get the midpoint, or how do we use the midpoint formula if there are 2 points? So for example here, if I have a point, let's start with a horizontal segment. Here, the point here is 0, 1, 2, 3. So this is -3 and 2. Here it's 1, 2. Again, we want to get the midpoint of this segment here. That's the midpoint. So clearly 1, 2, 3, 4, the distance between these 2 points is 4. So the midpoint is somewhere here. So the midpoint is -1 and 2. Notice that they have the same ordinates because the segment is horizontal. So we will no longer get the difference or the average between the ordinates. We'll just simply get the average between the abscissas, which are 1 and sorry, let me do it again. The average between 1 plus -3 over 2, which is -2 over 2 is -1. So here we could say that the coordinate of the midpoint is -1 and 2. So it is correct. All right. If it's vertical, let me erase. The segment is vertical. Again, if the segment is horizontal, simply get the average of the abscissas. If the segment is vertical, get the average of the ordinates. So example, if I have a point here and another point here, so this is 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, -1, -2. So the coordinate here is 4 and 3. This one here is 4 and -2. Again, the ordinate and abscissas are the same because it's a vertical segment. So midpoint, looking at the figure here, obviously the midpoint could be here. Am I right? So if looking at it, we could have 4 and 1/2. 1/2 for y. Let's check if it's correct. Again, the abscissas are the same. Simply get the average between 3 plus -2 over 2. So this is 1/2. Obviously, the y or the ordinate is 1/2. Okay, that's good if, again, the segments are either horizontal or vertical. What if segment is slanting line or not? Not vertical, not or horizontal. I'll give an example. For example, we have points -7 and 6. So -7, 1, sorry. Let me use a blue one, red one. So black. -7, so we have 1, -1, -2, -3, -4, -5, -6, -7 somewhere here, and then 6. So 1, 2, 3, 4, 5, 6. So somewhere here, the point is somewhere here. And -5 and -1. So -5 and -1. So this is the segment. This is the segment that we're going to get the, sorry, what happened to my line? Let me draw it again. This is the segment that we're going to get the midpoint. Now we can no longer use the method or the process that we used a while ago because the line is no longer horizontal nor vertical. So let's have the average between the 2 points. So average between the x, so the x sub 1 and the x sub 2, again the average, so divided by 2, and the average between the ordinates y sub 1 and y sub 2. So this will be the coordinate for our midpoint. Right? Using the example, our x sub 1 is 7, -7, and our x sub 2 is -5 over 2. We use comma here because it involves coordinates. Okay? And then our y sub 1 is 6 plus -1, which is our y sub 2 over 2. So we have m, -12, -7 plus -5, -12 over 2 is -6, and 6 minus 1 is 5 over 2, it's 2.5. So obviously it's in the second quadrant, negative and 2.5. So it could be -6 and 2.5 will be somewhere here. This is the midpoint. Let me remind again that the midpoint divides a segment into 2 equal parts. Excuse me. Sorry. So there are other things, or there are other geometric problems related to geometry which can be solved using the midpoint and a distance formula. For example, let me just erase this one here for a while. For example, you are given one side of a square only. So let's just say a side, this segment here is a side of a certain square. But you're asked to determine the area or perimeter of the square. So this point here, 1, 2, 2, and 3. Well, this one here is 2 and negative 2. Just given this one side, we can use this to determine the area of, if this is a side of a square, we can use this information to get its area and perimeter by simply getting the distance or the length of this segment using the distance formula. So that side could be equal to the abscisses are the same. Simply get the absolute value of 2, negative 2 minus 3, or the other way around. This is, the side is negative 2, negative 3 is negative 5. The absolute value is 5. So the distance or the length of this side is 5. 1, 2, 3, 4, 5. So we can use the formula for the area of a square is s squared. So 5 squared is 25. Now the perimeter is 4s. So 4 times 5, it's 20. So using the given one side only on a coordinate system, we were able to use the distance formula and solve for what is asked in the problem. Alright? And there are other applications of the distance and midpoint formula in solving real-life applications of plane coordinate geometry. I hope you are learning, and I hope you are ready for an activity or a quiz. And don't forget to subscribe to my YouTube channel for more videos, lesson videos in mathematics. Thank you and have a nice day. Goodbye.